Hi, it's Mrs. Pope, and today we're going to be talking about properties of real numbers. So there are real and imaginary numbers. That's a whole nother story we'll get to later. But today we're going to talk about the properties of these real numbers, and we're going to classify them by their properties and by what these real numbers can do. So our real numbers can be broken down into rational numbers or irrational numbers. When we look at rational numbers, because of the word, can be written as a ratio or a fraction. These can be broken into three different types. We have integers, whole numbers, and natural numbers. Our integers, I put a few examples here for you for whole and natural, but integers include negative numbers, so you want to keep that in mind. These actually include negative numbers. Whole numbers are only positive numbers and zero. And then the natural numbers, those are our counting numbers, and they do not include zero. So you want to keep that in mind. And these are all rational numbers. They can be written as a fraction. So notice even an integer, 8, that can be written as a fraction. It would just be 8 over 1. So irrational, these can't be written as a fraction. They are decimals that go on and on and on forever. And two examples, maybe the number pi, which is 3.141519 forever and ever, square root of 3. You could probably come up with a lot more numbers that are irrational. They cannot be simply written as a fraction. 3/4, if you think of that, would that be rational or irrational? Well, it's a fraction. It's 0.75. It's a decimal, but it can be written as a fraction, which would be 3/4. All right, so let's see what these real numbers can do. First, what I want you to do is name the set. So hopefully you've paused, you have that written down, and now you have all of your properties written down. I want you to tell me which ones these fall into. So negative 23. It's going to be a real number. All of these are going to be real. So we know it's going to be real, but it's also, you want to think, is it rational or irrational? Well, it's rational because it can be written as a ratio because it's a whole number. And now, is it an integer, a whole number, or what is it? This one actually is an integer. So I'll do two more with you, and then I'll leave you to do the rest on your own. Radical 50, square root 50. Of course, it's real. If you take your calculator, you'll see that you'll get a decimal that's not terminating or not repeating. So this one actually ends up being irrational. And let's look at negative 4/9. Let's see, we know it's real. All of these are real. And is it rational or irrational? It's just going to be rational because I can write it as a ratio. So remember, I want you to tell me whether it's real, rational, irrational, as many as you can that it can fit into from the previous slide. So I want you to do negative 185, negative radical 49, radical 95, and negative 7/8. Tell me all that you can tell me about them and which number sets they belong to. Okay, the next slide is very, very, very important. Very important. These are the real number properties. They may seem like common sense. They are common sense. But it's crucial that you understand these addition and multiplication properties because they come up a lot when we're proving things, when we're solving things. So we need to know these like the back of our hand and what their terms are. So when you move further in math, you'll be asked to talk about how is this related to the commutative property? Well, if you don't know what the commutative property is, you know this already. Everybody knows that A plus B is the same as B plus A. That's not hard, but we need to make sure we know that that's called the commutative property. Okay, so the commutative property, I just talked about it with addition or multiplication, A times B, B times A. Associative, this is where you can move the parentheses. If you have two numbers grouped together, A plus B plus another number C, you could also write that as A plus B plus C together. Notice the parentheses can be moved around here as well, and you'll get the same thing. The identity, there's an additive identity, which is 0. So anything plus 0 is just itself. And there's a multiplicative identity, which is 1. So anything times 1 is just itself. Again, I know it's self-explanatory and common knowledge, but we need to know that this is what these properties are called. Inverse, if you have A plus negative A, they cancel each other out and you get 0. Because that would just be A minus A. Or if you have negative A plus A, you would get 0. And for inverse, A times 1 over A is going to be 1 or 1 over a times a is going to be 1. And last but not least, the distributive, one that you've probably used very often. If you have a times the quantity b plus c, you would distribute that a and turn it into a times b plus a times c. And vice versa. If you have b plus c times a, you would just distribute that a, or distribute the b to the a, it doesn't matter, and end up with ba plus bc. Now notice, these look different, but because of what property up top can we tell these are the same? Just something for you to think about. What's that property? All right. Now, this is your work for you to do. I want you to name that property. These 4 are for you. I want you to come in tomorrow and just tell me, is this distributive, associative, commutative? What is it? Tell me these 4. 2 times the quantity x plus 3 is equal to 2x plus 6. Negative 7y plus 7y equals 0. Quantity 16 plus 7 plus 23 is equal to 16 plus quantity 7 plus 23. 84 plus 16 is equal to 16 plus 84. Tell me what those properties are when you get in tomorrow. And thanks for watching. Remember, you are responsible for your own learning.